issues with connections, or if you miss class for one reason or another, which I hope you don't, then you can always go to YouTube. And I always make sure I upload it probably the next day, if not the same day when I'm done with it. But today I'll probably have to update it tomorrow because I have to travel after this. Okay.
Okay.
All righty. So let's see, what do we have today? Again, our classroom on Google. It has information for anybody. Once you give me your email, you should be able to access it at any time. You know, you can also send messages on there to help you keep track or remember things that, or questions. If you have a question and you don't want to forget, you can always ask it there and I'll reply. So we are.
So please, how do I give you my email after the session?
Oh, yes. You can text me your email through WhatsApp or any of the phone numbers that are on the flyer. So let's jump onto the flyer anyway. And you guys see my screen? Can everybody see my screen? Okay.
Yes, please increase the size.
Yes, on there you can see information on the flyer.
But the contact, I'm not seeing the. Okay.
Yeah, let me go ahead and open the other one. Better. Okay. Yeah, and and the other thing is the schedule. So actually, let me go straight into our content. So from our schedule, obviously I don't have it on here. I had it in the other one. Today we have to talk about hardware and software, right?
Yes.
Yes.
So let's see, does anybody know on top of their head, what do you think is hardware? What do you think is software, in your own words?
Well, for me, I think hardware is the touch and see parts of a computer. Or is it just of a computer? Yes, the part of the computer, the visible parts that you can touch, you can see, you can feel. That's hardware.
That's very true, which makes software the invisible part, right?
Yes, like the programs and all that.
Yeah, so today we're going to go in depth, not really in depth that much, but you're going to understand the dynamics of, how computers came into existence in the first place. We're just using computers today, but there are many different types of computers. There are many different generations, It all started, by having a computer that can actually fill up an entire room, okay? So that was the very first computer. So we'll talk about that. And let me jump into our outline for today. So where is my plus sign?
Yes, good morning, sir.
Good morning. Can you hear me?
Yeah.
Okay. So do you have a question or do you have something to share concerning hardware and software?
No, I don't have any question for that.
Okay. All right. So today we're going to understand, how computers have changed, how they have evolved, right? And then we're going to talk about the two main components of computers, which is hardware that we can see and touch, and software which we cannot see or cannot touch. And we're going to differentiate them, so we'll talk about the different types of hardware and the different types of software, also giving examples in them. The first day we talked about the five big tech companies, right? Facebook, Amazon, Microsoft, Google, and Apple. We went ahead last week and talked about different career paths, areas in which we might be interested in, how we can go about learning it. But this is the fundamental thing that no matter what programming, IT, or computer science or information systems you're in, you need to be able to understand this. Once you understand this, life for you is, so this is the most fundamental thing you can learn about computers. And then from there, next week, we'll start learning about internet and websites, which is going to be more interesting, you know, but this might sound boring, but I can guarantee you, you're going to leave today with at least 1 or 2 new things that you learn, or probably a lot more, okay? So hopefully we can spend about 1 hour in the presentation. I'm not thinking we're going to take that much time. To begin with, I'm going to start by showing you guys a video. There are 2 videos here that I actually recommend. We have the 7-minute video and the 8-minute video, but I'll probably start with the 7-minute video. And then from there, we'll start talking about how computers have changed and the major components within computers. Does that sound good?
Yeah, it does.
All right, so let's go in and watch this short video, about 7-minute video talking about generations of computers. And
create a professional logo.
Obviously, it's always going to start with a commercial until I stop that. So
Electronic signals.
Let's go from the beginning.
Electricity was invented, so computers began using electric power. This led to the rapid development of computers. Let's discuss how the modern computer evolved generation after generation. The computers that were developed from 1942 to 1955 were called the first generation computers. The first generation computers used vacuum tubes. A vacuum tube consists of a glass bulb and wire. The wire is used to carry data in the form of electronic signals. The first generation computers were very large, expensive, and required huge amount of electricity. The ENIAC, or the Electronic Numerical Integrator and Calculator, was a first generation computer. The second generation computers were developed between 1956 and 1964. Now, what is the difference between the first and second generation computers? The second generation computers used transistors instead of vacuum tubes. As transistors are smaller than vacuum tubes, the computers became much smaller in size. They also became faster and cheaper. (1965 to 1975) was the period of the third generation computers. Integrated circuits were introduced during the development of the third generation computers. An integrated circuit, or IC, is as small as a transistor, but it can work as fast as thousands of them. Integrated circuits made computers faster, cheaper, and smaller than the second generation computers. They used less electricity and made fewer mistakes. The computers developed since 1975 up to the present are called the fourth generation computers. The fourth generation computer uses microprocessors. A microprocessor consists of a small silicon chip on which thousands of circuits are placed. The fourth generation computers are smaller, portable, and cheaper. They use less electricity and produce less heat. Computers that are currently being researched and developed are the fifth generation computers. These computers are the most advanced computers. Scientists are now trying to develop fifth generation computers in a way that they can think on their own. This is called artificial intelligence. Robots work on this technology. Now try to answer this question. Which of the following terms is associated with the development of fifth generation computers?
So we're talking about different terms, right? We've talked about generations from the first to the fifth generation of computers. So which of them is a fifth generation computer? Artificial intelligence, vacuum tubes, or transistors?
Artificial intelligence.
That's
Intelligence.
Yep. So that's where we are heading to. That's the future. Right now, we use microprocessors. Microprocessors are just a chip. You know, usually when you buy the computers nowadays, or last 10 years or so, it's a Pentium chip, or you know, Intel Core 3 or Intel Core 5 or Intel Core 9. That's the microprocessor. The microprocessor has many transistors on top of it. Transistors were not used in the first generation. First generation used vacuum tubes. So it was just empty space with glass around it and then wires to be able to transmit the information. But then second generation had transistors. Third generation had IC. And then the fourth generation, which is currently where we are at, has microprocessors. Okay, so let's carry on a little more.
Click the correct option. That's right. Scientists are trying to develop artificial intelligence with the 5th generation computers. Computers are made in different sizes so that different people can use them for different purposes. Let us discuss them. Supercomputers are the most complex computers. Supercomputers are used by people who need to process complex and large amounts of data. Supercomputers are used to solve complex numerical problems, make forecasts, and analyze scientific or engineering problems. Mainframe computers are large and expensive. They have powerful processors and very large memories. Hundreds of people can work on a mainframe computer at the same time. Mini computers are smaller and cheaper than mainframe computers and have less processing power. Mini computers can process large amounts of data. Unlike mainframe computers, fewer people can work on a mini computer. Microcomputers are the most common computers. They are used by businesses, at schools, and at homes. Only one person can use them at a time. They are also called desktop computers or personal computers. Laptop computers are smaller but costlier than desktop computers. They are also called notebooks. They can be operated with a battery, and as they are portable, they are mostly used while traveling. Mobile devices and tablets are smaller than laptop computers. Tablets are used to organize information, play games, and read e-books. Look at the image. It shows an embedded computer. An embedded computer is a microprocessor that is fitted into a device to control its operation. Embedded computers are installed in smart appliances and automobiles to perform special operations. Now try to answer this question. Which of the following is used to organize appointments and daily schedules?
So if you had to organize appointment and daily schedules, are you going to use a mainframe computer, a tablet, or a mini computer? Sounds like a tricky one, right?
For me, I think you use a tablet.
I think a tablet.
That's right, the tablet is correct. Mini computer, you have many people connecting to that, right? Mainframe computer, you have a lot more people. So if you say you work for a bank, everybody in that bank, maybe 2,000 employees or 1,000 employees, all over the country, they'll be connected to a mainframe computer or all over the city. And then if you have maybe an ATM machine, you don't need all the employees connecting to the ATM machine. Maybe you can use a mini computer on the ATM machine so that an operator can connect to it. Somebody that's also doing maintenance can connect to it and so on. But tablet, again, it's for personal use. So one person at a time is using it, just like your personal computer or microcomputer. Sounds good?
Mm-hmm.
So at least we can tell the differences between the generations of computers and the different types of computers. And with that, now we can talk about the different components of a computer. Okay, so again, this picture you can access it on the notes online. It tells you about the first, second, and third generation and examples. One thing you should note is that the years are not really that important because they fluctuate. You know, some people might say, hey, it was 1940, some may say it's 1941, and so on. The big deal is just about the type of computer at that time, and so on. You notice that the first time we talked about, the first day we talked about Microsoft, Apple, and so on, they actually started around the 1970s. That's when, instead of, you know, people having computers filling an entire room, they tried to make things as small as possible, but also fast and more accurate, so that you can actually have a computer all in one. Before, you had to buy different pieces and then go back to the store will put it together for you. But now you're buying something that has already been put together. So that's how the fourth generation computers were born. You know, you just go in, they give you a box with all your computer stuff, you connect the cables, and then you're good to go. Okay. So let's talk about some definitions now. A computer, we've learned, is a device that transforms data into meaningful information, right? It takes something that you input. You know, there are many ways you can input information into a computer. And with that input from the user, it gives you a desired output. You know, for instance, a computer only does what you tell it to do. So the two major components now are the hardware and the software. So computer, again, does not necessarily mean it's your laptop or your phone, or rather your laptop or your desktop. Your phone can also be a computer. Your car can also be a computer. An aeroplane can also have a computer because they have that embedded computer. They have a microchip that's in there with instructions that when they press a particular button, maybe a fan stops turning. If they press another button, maybe in the airplane, the tires will go down, and so on and so forth. So you're just giving it instructions. The one thing I want you to remember is that those instructions, they're just based on electricity. So the only thing that a computer understands is ones and zeros. If there's electricity going through, then it's a 1. If there's no electricity, it's a 0. So they have made it change so many times that you can have different versions of ones and zeros to signify a particular letter, and different versions of ones and zeros to specify a particular word. So with that, think about the road that you use when you travel. You know, if there's just 1 or 2 lanes in the road, there are very few cars that will go through. But if there's more lanes on that road, then more cars can go through. So the more the lanes, the faster the transport or the information is being transferred. Okay, so I'm going to talk about that in a little bit once we talk about the different types of components. So the first component, again, is the hardware. Hardware refers to something that you can touch, you can see, it's physical, it's tangible. Okay, the different types of hardware that are used. Okay, they're the primary electronic devices that build up a computer. For instance, your monitor, because you can see it, your keyboard, your memory card, your mouse, and so on and so forth. Even when you open the computer, you're going to see maybe a hard disk or a CPU, and so on and so forth. Those are all hardware. Software, again, is just instructions, procedures, and documentations for you to perform a particular task. So software, there are different types of software as well. You know, there's an operating system. It's an example of a software. You know, it governs all the other softwares like Windows operating systems, Mac operating system. And then you also have some software that are specialized. For instance, antivirus software or antivirus software. That's also a specialized one. You also have Excel, Word, and even your web browser that you're using, your Google Chrome or Internet Explorer. Those are all software because we cannot touch them. right? We only send instructions to them, and those instructions are sent to the machine. Does that make sense?
Yes, it makes sense, but have a little worry. The part where it says that there are the parts that you cannot touch and see. But this one, I think with software, we can see, but we cannot touch. So
Yes, you can see, but you cannot touch. That's correct. What I mean is it's I don't know, it's just what you can see is actually the hardware. You can see the monitor. The monitor is displaying you those instructions. You cannot see the instructions. The instructions are within the software. The instructions are then translated by the hardware to be able to display. It's just like sometimes you might, play a music, right? You may use, say, VLC. VLC is a software that you use to play videos, right? Or you can also use iTunes, which is another software that you use to play audios. When you play the audio, you hear the output, but you cannot see it. You cannot touch it. So that's another output device. A headphone or a speaker could be an output device. But what we can see and touch is the device, the hardware. But what we get out of the hardware is the software. The output is part of the software's output. Does that make sense?
yes.
Yeah, so it's not tangible. We cannot touch it, but we can see it, we can hear it, we can feel it, and so on. Okay.
Yes.
Very, very good. So hardware, again, we've talked about the definition. It's physical. Physical, we can touch it, right? We can also see it, But some examples, very common examples are CPUs. Everybody knows what a CPU is.
Mm-hmm.
The CPU
Yes. Yes.
is a central processing unit. Okay. One thing that people commonly say is that computers, or their sense, that computers are smart. Computers are not actually smart. Computers are very, very dumb. The only thing that computers have more than us is speed. So computers have a lot of speed, and this is because of this CPU, the central processing unit. What a human being can take 1 minute to do, a computer, what a human being can take 1 hour to do, a computer can take less than a second to do it, because it's sending so many instructions in a millisecond. Okay. A joystick is the stick that you use is just like a gearbox when you're playing video games and so on. Also, we use these devices to control the computer's operations, like the input and the output. Okay. So hardware components are further divided into different categories. We have input devices, the stuff that you use to insert commands or insert instructions into the computer. Output devices that we get response back, and storage devices. Storage devices can be of many different types, and they have been evolving so fast and so many times. We'll also talk about those briefly. Next is the internal components, everything that is currently inside a computer. So in a computer, you have different things that are inside that we cannot see outside. They're covered with a case. We'll talk about those as well. So if we want to break down those different hardware types, you can see that, oops, I should. So there are 4 main different types of computer hardware in computers, right? Computers component, a different category is hardware. If we look at input devices, mute that end. Okay. Input devices could be barcode readers. So for instance, when you go into a supermarket and you buy something, they'll use a scanner and scan the barcode. It's going to read that and give them the information. That will be an example of input devices. they're taking that code and inputting in the system, it automatically brings up the name of the product and the price, and then you're able to pay that price that it shows up. A joystick is a controller that you use for video games. When you push it to the right, your actor goes to the right. When you push it to the left, maybe if you're playing FIFA, the soccer player goes to the left, and so on. Keyboard, we are all familiar with keyboards. It has lots of keys, input keys, number keys or word keys, and so on. And mouse as well, everybody's familiar with that. And OCR is a device that you use to be able to read text and then translate it. Let's say read a picture, optical. I think I've forgotten what the full meaning of OCR is. It's optical calibrator reader or something like that. So it reads somebody's handwriting and then changes it into text. So if you write a whole story in a paper, you can actually scan the paper and it's going to transfer it for you. So that's an input. Now a pen, we're all familiar with that. You can use a pen to write on your cell phone or write on your tablet or even on your computer. Scanner as well, we're familiar with those, and webcam, that's what we usually use when we have video conferences. So those are all different types of input devices. Output devices also vary. GPS, we're all familiar with that. Headphones for audio, monitor for video, a plotter, again, if it's a case of geography, to be able to plot a graph. Printers, again, we know that, printing out documents. Projectors, very similar to monitors, but having a bigger picture. A sound card usually goes into the computer, but it's what converts whatever input is being entered into the computer into a sound. Without a sound card, the computer will not be able to have audio. And the speakers are usually tied in with those as well. So speakers, very similar to headphones. Speech synthesizer, this would be an example of changing text to word, what is usually known as text to speech, and also speaking it out for the user to hear. Video card, very similar to sound card, goes into the computer, converts all the instructions into video. So that's it for input and output devices. So computer pretty much takes an input, converts it to an output, but it needs that device to be able to take the input, and it needs the other output device to be able to display the output or express the output. In order for computers to be able to take instructions, they have to have a way of saving it. In some cases, they save it and they remember it. In other cases, they save it and they forget it. So again, if you're going to save memory that's going to be persistent, then you need a ROM, random, or rather read-only memory, okay? That's one that you're only going to read, and it's a primary storage device. Another primary storage device is random access memory, also known as RAM. There are three different types of RAM. There's static RAM, which is fixed. There's dynamic RAM, where the memory can be shifted in different locations. And then there's synchronous dynamic RAM with random access memory. So think about, say you have, again, a bank where you have different vaults, different cupboards to save people's items. Someone comes in and say, I want to save my earrings. You go and put it in this area. Someone comes in, I want to save all my certificates, you put it here. Someone comes in, I want to save my diamonds, and so on and so forth. So that's how the computer has that random access memory. When you go and request and say, hey, I want my earring that I saved, it goes and grabs it and brings it back to you. Whether you turn off the computer or turn it back on, in this case, when you turn it on and off, it's going to forget it. But if it's something that is permanent, then whether you turn off the computer or not, it's still going to remember it. Okay. Does that make sense?
Yes.
Okay. Now for secondary devices are those that you can remove. It doesn't have to be in the computer all the time. But without the RAM and the ROM, the computer is not going to start up. And again, depending on the size of your RAM and your ROM, it's going to tell you how fast you can actually run. Because, for instance, your CPU might have very high speed of processing. Again, CPU, I'm going to explain that later on. The CPU might have maybe 3 lanes that you can have 3 cars going, or 2 lanes, or you could have 6 lanes or 8 lanes. But if you're not giving it enough instructions in the RAM and the ROM, that's where you store the instructions. So if you go in and tell them like, hey, give me 1 cup of water, and then they can only take 1 instruction at a time, then it's very difficult for you to transmit all that information very fast. So your computer tends to be slow. But if you have a higher amount, then you can transmit a lot of instructions at one time. Your computer will be fast. But now you have other examples, oops, I should probably go in here and change it. Sorry, I cannot type. That's fine, I'll go back to it later on. But I just noticed that I spelled memory wrong. But then you can have memory cards or external memory that can help you add more instructions and run faster, or maybe save your information and make it mobile and use it on other computers. So the first type is the flash memory. The flash memory can be of different types. You have the SSD, which is a static disk. And you have memory card. Oh, I don't know why this keeps coming up. You have a memory card, which we're all familiar with. Multimedia card actually goes in with cameras and others as well. A pen drive, just the one that you insert and remove, very different from a memory card, because it usually, I don't know if I should have some examples I should have showed you. Let's see. So this would be an example of a flash drive, maybe. Okay, with the pins you can see on there, and then memory card or memory stick would be something like that. So again, flash drives could be different types. It could be SD card, memory card, multimedia card, depending on the type of information that's being stored on there. All right. Now for magnetic, flash memory again uses flash, but magnetic disk were what were used before we even had flash memory. So magnetic disk, the very most important one is the hard disk, which we know is in our computer. We also have magnetic flash memory. That was a lot faster, when they went ahead and did that. Magnetic cards are also inserted in a computer. But back in the days, it all started with magnetic tape cassettes. So think about the days when the first rockets were being sent in the moon and so on. But in recent memory, around the 1990s, we also had floppy disks. I'm not sure if any of you have used it, but again, all those things are not really being used because we have flash memory right now. Now, in addition to magnetic and flash memory, we can also have optical storage. Optical storage has to do with things like CDs and DVDs. CDs have a lower capacity, DVDs have a higher capacity. Blu-ray discs have an even higher capacity. They can store even more information. And for CDs and DVDs, it could either be just read only or read and write, where you can actually read the information and you can actually burn the DVD or burn the CD. Sounds good?
Mm-hmm.
All right, now
Yes.
internal components are the ones that are usually interesting, okay? So these are the things that are usually within the box of the computer, be it a desktop or a laptop or tablet or whichever one. So they actually have a few. Let me go back here. Nope, not in there. never mind, I don't have that picture on here. So they actually have three main things. They have the ALU, which is where you actually, I think I'm hiding a few pages, but I cannot see it. Okay, there they are. Okay, so you can have, I needed to change that. Sorry, this spelling was driving me crazy. I need to change it. Okay, so you can have the CPU, which, like I said, is very, very fast. Okay, it's not smart, it's just fast. It takes a lot of instructions at a very short period of time. Okay, so what the CPU does is it just sits on your computer and keeps waiting. Like, hey, feed me with instructions. What do you want me to do? What do you want me to do? What do you want me to do? The arithmetic language unit on its own now actually does more because the computer can only understand 1 and 0s. So way back when, the very first few generations of computers, everything was being built using machine language. Okay. So after machine language, let me go ahead and make sure that I added this as well. It should be right there. So since the computer can only understand those particular languages, I think I'm missing something very critical here. Where did it go? Take it out. Yeah, I did. Yep, I took it out. So computers can only understand, machine language. They can understand 1s and 0s. So 1s and 0s were put together to develop what is known as machine language. Machine language was very difficult for anyone to understand. You had to really memorize it. Very, very few people could do it. But a step further, which I should go in and just type it in here. A step further, you had assembly language. Assembly language was a little bit easier. So assembly language, they'll come up with a few things that have been assembled. And based on that assembly, they would go ahead and convert that information to machine language, and then machine language will convert it to 1s and 0s, and then the computer would understand. Okay. The next other one is high level. High level language. So high level language is what we know, like the Java, the Python, and so on. So again, in this one, we human beings can actually understand it better. You can type words in English and French or whatever language that actually means something that can be transferred to each of those. So the arithmetic, the ALU, the arithmetic language unit, actually uses these translations to be able to transfer them. So if you look at the link I have in here for hardware, let's go in and take a look at that. So for the ALU, again, this is what I needed you to understand. What is inside this box is what is enclosed within your computer. You have your input device, depending on whichever input device you have, is going to send instructions. The instructions are going to be saved in your memory unit, okay? We've already talked about the different types of memory. It could be flash memory, it could be optical memory, it could be primary memory, okay? When it's stored in the memory, based on the 1s and 0s, it's going to use the arithmetic language unit. This ALU will then convert that instruction and send it to the CPU, the control unit. The central processing unit now converts it, does what is expected of it at very, very high speed, because it has, all those transistors that are now embedded within that microchip. So the microchip that is being created for the 4th generation computers has a lot of transistors in there that carry out these instructions. And then we finally come up with our output. Now the ALU, the way it works is that it takes, where is my instruction? Hiding behind here. Unfortunately, I can't find it on there. Okay, let's see if I can find it there. All right, there it is. So the ALU then uses that different languages, okay, based on the type of language that is being utilized. I think I should have had it in the other one instead. It uses either the assembly language, the machine language, or did I not type it in here? Or the high-level language to be able to decipher that instruction. So what programmers usually do is they write code in these languages to be able to give instructions to the computer to be used, okay? Now, all of that, all the internal components are usually placed on a motherboard. So the motherboard is just, say, like a placeholder for you to go in and fit in all those different pieces. So the motherboard will consist of your, say, the fan, because the fan is needed for it to cool the machine since it's running hot. You will also have the CPU, the microprocessor chip. It's going to have the hard drive, and any other devices as well. It's going to have connectors to the input devices and connectors to the output devices, and so on and so forth. So does that make sense? Does that clarify what hardware entails of?
Yes.
Yeah.
All right.
Yes.
Any questions? So the key thing here is that hardware has not really been changing that much, apart from making it faster and smaller. There isn't much else that can be changed. The most changes that take place in computers is based on the software. That's why some people think that hardware is not a lucrative field to study, but hardware is very important because the key is we want to keep making things smaller and faster and also better and more accurate, okay? So the main thing is understanding that this is about electricity. Electricity goes in or goes out. If you look at the printers or most of those connectors, even the one I just showed you, let's see, the flash that I showed you, if you look at the pins, they usually have 8 pins, okay? Those 8 pins are usually bits and bytes. So if there's current going into each of them, then it means a different instruction, or if current is going into just 1 or 2, okay? So that takes us into what we know as 32-bit and 64-bit. Have you guys ever heard about 32-bit computer and 64-bit computer?
Yes.
Yes.
Oh, it's a 32-bit and 64-bit. So again, a bit is either a 1 or a 0. Again, 1 is presence of electricity, 0 is no electricity. So if you have 32 bits, it's usually having these 8 pins and having up to 4 signals sent per second. So you have 8 times 4, 32. So think about a road that has 4 lanes, and you're sending instructions on those 4 lanes. But then if you expand it and have 8 lanes, which will be 8 times 8, that's what will give you 84 bits. So 84 bits are a lot faster. If you look at it in terms of binary, 32-bit is actually 2 to the power, I don't know how to write it on here. 2 to the power 32, okay? Meanwhile, the 64-bit will be 2 to the power 64. So this will be a lot faster. You can only have a maximum of, I think, about 800 megabytes of speed in this. But for this, you can have up to 2 terabytes of speed. So if you have a 32-bit machine, there are many things that you might be having issues with. You know, they're not really being created nowadays because there's no need to create a smaller one compared to a bigger one. Because, you know, the bigger one, you can store more information can be processed faster. So you can only get up to that amount. Now, if you start having software that's running that needs up to that that amount of space, say you're trying to carry a trailer of information, that trailer cannot probably go on a road that is just four lanes, right? You need to be able to upgrade to a 64-bit, and then you'll be able to use that software. So some software do not work on 32-bit, but everything that works on 32-bit should be able to work on 64-bit. Now, before you start thinking about software and hardware, there's something known as drivers, which we'll talk about hopefully. But the driver usually comes with the software to be able to install it so that the computer can really understand what is needed of it. So a driver, again, sits between the hardware and the software. Does that make sense?
Mhm.
All right, so let's jump into software. That way I don't take up too much time. So software, I'm missing the definition. Oh, it was right there. So computer software, again, is a collection of instructions, procedures or steps, documentation that performs different tasks on a computer. One software might be for addition, another software might be for typing or reading and so on, another software for playing music or watching videos or changing pictures and so on and so forth, or maybe going to the internet. So the code that can be machine level code or the code written for an operating system is what is actually driving the software. So if you say I'm a software developer, it means I'm able to write code that a computer can interpret or compile or assemble. So that takes us back to the hardware I was talking about earlier. This one. So if you have machine language is understood by computers. But if you have assembly language, if you need to compile your assembly language or make the computer understand your assembly language, you need something known as, so this is in the ALU. The ALU has what is called as assembler, okay? The assembler converts assembly language to machine language. But if you write your code in high-level language, then the ALU will have to use what is known as a compiler. The compiler translates the high-level language to machine language. And then finally, if you want your machine, your computer to work a little bit faster, maybe, and also to give you errors before you execute it, then you use the ALU's what is known as interpreter. So the interpreter does high-level language, but it does it line by line. Does that make sense? So if I write a bunch of code, if I write a lot of instructions, and say I write 20 instructions, like go and carry water, come and wash the plates, put on the fire, cook this food, and so on. Once it gets to the part that there's an error, it stops right there. It doesn't continue the rest of the instructions. So that will be an interpreter. It interprets line by line and stops when there's an error, but it does it a lot faster. But the compiler is going to take all those instructions and then try doing it at once before it will stop. Okay, but we don't really need to know about the details of that, but just understand that Machine language is what the computer understands. Assembly language can be turned into machine language using the assembler. Meanwhile, the high-level language can either be done in one block using a compiler, or it can be done line by line using an interpreter. Make sense?
Yes.
So let's go back into software. Software, again, we've said is what we cannot touch, right? Because it is that code that does all the different things we need. But software can also be differentiated into different types of software. Okay. The software could be system software, application software, or utility software. A system software actually sits on top of the hardware. The hardware is what we are interacting with or we're getting information from. So the system software is between the user and the hardware, okay? The very basic one, which you would see often, is the BIOS. BIOS means basic input output, okay? Basic input output system. But now it's being replaced by the UFI, which is, I think is Unified Extensible Firmware Interface, okay? So it's being replaced by that because it's more advanced. You know, the BIOS from way back when we had MS-DOS has never changed, but you know, there are different ways that we can actually process information. So once you turn on your computer, when your computer starts booting, this is usually what starts running first, because it's making sure that your computer can interface with the hardware that is being used for input and the hardware that's being used for output. So once all of that has been established, like, yep, all the connections are good, then the computer comes on at that time. But then BIOS will be slower. UFI is a more advanced mesh technique. So that's why, you know, all computers with BIOS usually take a long time to come on, but the new ones with UFI, they turn on a lot faster, okay? Device drivers, again, that's what we're just talking about. It helps you to be able to, you know, for instance, you go to the market, or sorry, you go to the farm and, you know, harvest your food. You're going to need a driver to transport that food to the market. So the driver takes in whatever your actual software is and connects it to the hardware, makes sure that the hardware is in place to be able to support that software. The language processor, which is what we were just talking about, is also part of the system software. That's the assembler, which, as we said, it converts the assembly to machine level language. The compiler, which compiles the high level language to machine level language. And the interpreter, which actually does it, the same thing the compiler does, but line by line, okay? So I think we've already talked about that. Now, the big one is the operating system. The operating system, again, it's impossible to have a computer without an operating system. We know about Apple Mac operating system. Understand that operating systems have different editions and different versions. They always upgrade them or update them and so on and so forth. So, you know, depending on the year, you have a different type, depending on the use, if it's enterprise or personal and so on. Most phones also have operating systems. It could be an Android operating system or an Apple operating system, iPhone operating system. You also have tablets, and you also have another new generation of devices known as Chromebooks. Chromebooks usually use the Android operating system, okay? Now, finally, we have Windows, which is the most popular by far. And that's why you usually have antiviruses or viruses attack Windows, because Windows is the most popular operating system. Now you also have Linux. Linux is technically not really an operating system, but most people like it because it's lightweight. You know, you just have all the basic things that you need, and then you start adding more stuff as you need. It does not even have a graphical user interface. You cannot use it the way you use Windows, because everything is done on the command line. but it can be packaged with whatever user interface that's out there in the market. So by itself, it's free, open source. But then, if you want to set it up in a particular way, then you have to start paying, maybe pay some people to do it for you. Unix, again, is very old system. It was, it's actually what is being used to run Linux and also Mac operating system, but it's very primitive. Very few people use it. But even if you have those very old computers, if your old computer cannot work on Microsoft Windows because it's heavy, your computers should still be able to run on Linux and Unix. Just use the bare minimum things that you need the computer to do. You should be fine. If it's just going on the internet or if it's just doing a few computations or just for a particular software, then you should be just good. Make sense?
Yes.
So operating system, you can have a lot of them. I mean, think about Windows, from Windows 85, Windows 95, Windows XP, Windows 7, Windows 8, all the way to Windows 11 now. So those are all different versions. Okay, next up, let's talk about application software. Application software is what is commonly known as apps, right? An app, there's an app for this, there's an app for that. Most of them are general purpose software. See, like Microsoft Office, you can have different types of, products in there, Excel, Word, PowerPoint, and so on. You also have media players, whether it's Windows Media Player or it's VLC. You can also have social media, or you can have web browsers and so on. Those are all software or application software that actually depend on the operating system to run. Okay, by themselves, they cannot run. Operating system by itself runs just fine, but the application software needs the system software to be able to function. The final one is the utility software. Think about this as a toolbox, right? These are the things that you need to be able to fix your system or prevent your system from getting broken. So things like the disk defragmenter tools, text editors, antivirus, the most basic things that you need on your computer. So what questions do we have so far?
I'm still trying to process it. Maybe by next class. This one is a lot of stuff today.
Yes, it's a lot of information, but you cannot remember all of it at once. But you can always go back again to the outline as I explained to you. Watch the other video. The video is a little bit fast, but if you watch it and slow it down, you can probably catch it on, but the key here is to be able to understand the computer history and how computers have changed over time, right? We have understood, way back when in the 1940s, you need a whole dedicated room to have a computer. Not like now that everybody's walking around holding a computer in their hand. That's how far we have progressed. Back then, you have to first of all have a room with the right temperature and everything. You go into that room, you cannot probably stay there for 5 minutes because it'll be very hot with all the processing that was taking place. And then, the guys sat down and figured out a way, instead of using vacuum tubes, they started using transistors. Transistors now became the thing, and they reduced the size to maybe 2 or 3 computers in a room. And then they figured out, hey, we can use internal circuits. Internal circuits were then used to make it even smaller. And then when the guys figured out, we could get it to work in microchips, that's when they started, Silicon Valley. When they discovered that, they could use silicon chips to add into computers to make them a lot faster, better, and more accurate. Then, things started getting manageable. We were able to have computers, that you carry on your head. But now nobody can even carry a computer on your head. If a computer cannot fit in your hand, then it's not good enough. But I mean, that gives you an idea to be able to understand that, hey, everything, including us human beings, we are a work in progress. We don't really expect us to just start and know how things work. We have to put some work into it. We don't expect everybody to start and just understand computer science. But if you put your back into it, you're going to be, tomorrow you'll be thinking about, I can't believe I didn't understand this 10 years ago. But it's a process. But all in all, we are made up of the different parts of our body, just like a computer is made up of the hardware and software. Everything that you can see in a person, their hands, their feet, their ears, their eyes, that's like the hardware. But you cannot see somebody's feelings. You cannot see his anger. Maybe you can see his face showing that he's angry, but you cannot see his suffering. You cannot see his love. You cannot see his reasoning and his thoughts. Those are like the software part of, computers. And that's what actually makes you do something. If you're angry, you slap somebody, that's because of the anger that has moved your hand to be able to slap them. So that's the output. The input too, when you hear things, everything goes in either through your ears or through your eyes when you see it, or through your mouth when you taste it. Or maybe through your hand if you feel it. If you're feeling hot, guess what? Maybe you're going to take off your clothes. If you're feeling cold, you're going to take more jackets and put them on. But those are all reactions based on software, okay? Just like computers. But now to be able to troubleshoot them, you have to make sure you understand those 32 bits and 64 bits. That's usually the first place to check. If your computer is slow getting started, maybe check the BIOS, check the UEFI, and see, okay, is it compatible? Maybe you have a device in there that's connected that's not compatible. Maybe you have a software that is trying to load. It cannot load because it needs 64-bit, but it's only seeing 32-bit processing. Okay. Next up, maybe this 32 and 64-bit is not the issue. Maybe you just need to update your driver. Maybe the driver cannot, carry all the food from the farm to the market. So without that driver, that device will not work. Maybe you also had an update that you did not do, or you needed to upgrade your system. So all those different things, if you understand how software and hardware work, then you can troubleshoot your computer slowly until it starts working. If you have blue screen of death, if your computer is not just coming on, then okay, maybe my memory is full. Maybe I don't have a memory card. Maybe I'm using the wrong size. Maybe the size is not compatible with something else, and so on. So does that make sense?
Yes, it does.
Good. All right, so what questions do you have? I know we've learned a good number of words today. I can probably play the last video. Again, you can always get to these links. It will tell you about the different concepts, just like I've explained it. If you want to get a different view, you can see the computer being separated into software and hardware. The hardware could be the software could be system, application, or utility software. The system software, basically the operating system, which is Microsoft Windows, Apple's Mac OS, Linux, Unix, or Google's Android. Okay, language processing, you actually take that language from the software and use your ALU, your processor, to be able to assemble it from assembly language to machine language, or compile it all at one time from high-level language to machine language, or interpret it line by line from high-level language to machine language. But then you still need your device driver to make sure that everything is compatible, your basic input-output system, to be able to make sure that your input and output devices work perfectly with it. And the normal software, where most of everything relies, is either general purpose application, or specific purpose application. Specific would be maybe a hotel has a specific reservation system, or maybe a stadium or sports organization has a ticketing system, or maybe you can have a learning management system or a banking system. Those ones are specially made to be able to fit a particular industry per se. Utility software would be antivirus, defragmenters, and just regular text editors. Make sense?
A lot.
Good, 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 good. So any questions? Any questions you have? No questions?
I did not get the difference between the ROM and the RAM.
Awesome, awesome, very good. So ROM is read-only memory. Okay, while RAM is random access memory. Here, let me go into that more detail. So both of them are primary memory devices in a computer. Okay. Remember the difference between primary and secondary memory?
Yes.
So primary memory means you cannot remove it from the system. If you remove it, the system will not work. Secondary memory is just additional memory. Okay. So random access memory is one that you can access very quickly, but the moment you turn off your computer, it goes away. So for instance, if you're typing an email and you don't save it, that email is still in the RAM. The moment the computer goes off, it's gone. If you're typing a letter or you're working on a file, all the instructions that you're typing in there are going into the RAM and being stored randomly, and it's being accessed very fast. Okay, so what the RAM does is it holds the program's data while it's currently being processed at that point. So as soon as the computer goes off, that data is gone. But once you're done typing your line or your paragraph or your entire story, you can then save it. When you save it, it goes into ROM. Because at that time, it becomes read-only memory. Why am I losing this? Nope, I went to the wrong one. Once you save it, it goes into the ROM. Okay. ROM is read-only memory. You cannot change it again. Okay. Does that make sense?
Yes.
ROM actually stays with the computer, whether you turn it on or off, it's persistent. Okay.
That's when you've saved your story.
Exactly. Once you have saved everything, it then resides in the ROM per se.
So the use for the RAM is not really necessary now, because normally you have to save.
Yes, the RAM is used at that point in time. If you want to be able to do many things, maybe you have like 5, 10, 20 windows running, you're going to need a lot of RAM to be able to do that because it's while it's running. If you have very limited RAM, then you cannot open 3 windows, 3 software, 10 software at the same time. Does that make sense?
Yes, something new to me.
Yeah, so normally if you say my computer is slow, as the moment you open one file, open another one, computer starts looking at you as if you have a problem with it, then you probably need to upgrade your RAM. But in some cases, if you're using 32-bit, then you can only have so much RAM, you cannot go past the amount that is being allocated. That's why they'll tell you cannot use this computer to run more than 10 programs. You know, if you're using one of those fast computers, then you have more RAM, then hey, you're good. For instance, I'm using an old computer, the RAM is probably low compared to my other computers. Okay.
Please, I have a question.
Yes, go for it.
Yes, my question is that since you talk about the system software, and one of their example is BIOS and UEFI. I wanted to know the meaning of UEFI, please.
Awesome, awesome, awesome. So let's see. Where did I I think I have that in here. If I don't have it, I need to add it.
Sure.
Okay, I think I don't have it in there, but that was a very good, let's see, BIOS and UFI. So BIOS, again, like I said, was a really old method of using, checking your input and output devices that it's working, okay? So BIOS will be something like this. When you actually turn on your computer and you press F8 or F12, it takes you to a basic input output, okay? UFI on its own is more dynamic. It looks something like this. UFI stands for Unified Extensive Firmware Interface, okay? So it has a lot of features compared to BIOS. BIOS has only a few features, and it helps you create more support, okay? So we did talk about the 32-bit and 64-bit. UFI can work on either one of those, but I think BIOS is mostly on 32-bit. So think about BIOS as the olden days of doing things, of making sure that your input and output work correctly. And UFI is the new way of making sure, for instance, if you look at this image, it tells you, okay, this USB should be working okay, this hard drive is working okay, it's using USB. You can set up the priority. You can also do drag and drop. But if you look at the BIOS back in those days when we could not do drag and drop, you have to go in and use your arrow key, your arrow on your keyboard. You use your arrow to navigate from here to there. You cannot use your mouse in the BIOS. In the BIOS, you have to use your key, as it says here, press escape to quit, press F10 to save and continue, and then use the arrows to select an item. So that's the old school way of using. Nobody uses that kind of stuff anymore. Now, if you're using UFI, which is the Unified Extensive Firmware Interface, you can go in here and drag this and drop. You can click on there and see all the changes that are taking place. You can click on the drop down and so on. But back in the days, you have to use your arrow to navigate from one end to the other. Does that make sense?
Yes, yes, thank you.
Very good question. Very good.
Thank you.
The other thing is, I need to mention, even though you might go into your computer and you see the word BIOS, it might still be using UFI. The problem is that the issue is that they still maintain that word BIOS in the current system because they don't want to get people confused. So it will maintain that name BIOS, but underneath it's using UFI. So most of the time, if your computer stops working and so on, they'll tell you, hey, insert a USB UFI to be able to, run it or skip it or repair it and so on and so forth. I'm not sure if I can come up with a search for a page here. So let's see. Okay, so it will look something like this. These are the different kinds of error messages that you see with UFI. Okay. Yeah. For instance, this one is saying error BIOS legacy boot or UFI on the media. So this drive was created by blah, 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 and cannot use UFI mode only, or it can be put in UFI mode only. So all those error messages that you see when your computer is trying to boot up, that's what it's actually meant, right? This is another example for Windows. Your PC device needs to be repaired, blah, blah, blah. It will tell you to enter a USB that has that repair and so on and so forth based on this code. So normally it will tell you the file that is corrupted. Once that file is corrupted, you need to fix it to be able to proceed. So error messages that you get, that's how you'll be able to troubleshoot them. Yeah. Make sense?
Yes, yes.
Yeah, and the error message is usually when you're starting up your computer. Once you can fix that, then you've gone past the BIOS. If you can't get your basic input-output devices to work with your computer, then it will not start. But once it has established that everything is okay, everything is connected peacefully, the drivers are working just fine, then your computer is going to boot up, and then you can go ahead and do anything you need to do. All right. Okay, so what other questions we have before we go on today? Everybody good so far? Okay, so I know it's almost it's almost 7:30 in Cameroon, so I'm gonna let you guys go if you don't have any questions, but let me know anytime if you have any other questions that come up. Next week, we're going to talk about how we build websites, how websites work, what actually happens, and you know, it's very, very interesting topic. You know, it's very easy to do once you understand it, and very wonderful to do once you practice it more often. So again, we've gotten the fundamentals out of the place. We understand how files are stored and so on and so forth. We could take probably 3 hours just to learn hardware and software, or we could take 1 day or 1 week to learn one particular software or one particular hardware. But understand that this is just a fundamental, right? Because if you want to learn about keyboard, you probably take more than a week. If you want to learn about Microsoft Word, you probably take more than a month. If you want to learn about particular CPU or firmware or language, programming language, that would be another story. So everything on computer science, everything on IT is based on this hardware and software that we've talked about.
Okay.
Sounds good?
Yeah.
Yes, yes.
All right,
Yeah.
last call for questions before I let you go. No questions? All right, so let's call it a day, and I'll talk to you guys again next Saturday.
Thank you.
All right,
Thank you very much.
welcome.
Okay, goodbye.
Okay, goodbye.
Bye, enjoy.
Yes.